I start chapter 4 and section 4.1 is determine whether or not given point is the solution of the system. So let's say I have two equations, y equal 5x and y equal minus 6x minus 33. First of all, when you have two equations, both of them are linear equations. And graph of linear equation is a straight line. I call the linear equation because the power of x is 1. If the power of x is not 1, it's 2 and above, is not a linear equation anymore. So, so here, how do I graph y equal 5x? Anytime you want to graph a straight line, you need to have two arbitrary points. So here, let's say I put a 0 for x, and I substitute here, y is 0. I put 1, y is 5. And it's always better to have 3 points. If you have 3 points for x's, then you definitely come up with the right graph if all 3 points lie on one line. So let's say if x is 2, y is 10. So when I graph this, I have on the x and y axis, let's see. x0 and y0 is 1 point, x1, y5, 1, 2, 3, 4, 5. Let's say this is the second, 2 and 10. So these 3 points, they all must lie on one straight line. That's why I say you have to use 3 points, because in that means you understand that your graph is correct, right? So let's say I give you a point. I said, is this point is x equal 1 and y equal 7 a solution of y equal 5x. What does that mean? That means, is this point belong to that equations? What you need to do is you take this x and y and 1, 7. Well, you know it's not, because you see, if when x is 1, y is 5. But let's say you don't see this table. We just give you a point and this equation. We give you this equation and this point. And it said, okay, is this point belong to that equations? Then what you do, we just say, okay, let's say y equal 5x. Y is 7 and x is 1. No, 7 is not equal to 5. Then you say, no, this is not a solution of that equations. Okay? So let's say like in these equations, say is x equal 1, y equal 39 a solution of these equations. So what you do is you just take this x1 and y negative 39 and you substitute here. So then you see minus 39 in one side, x is 1 minus 33. Then you see both sides are equal. Then you say yes and no for this, okay? So anytime we give you a point and we ask you to verify whether that point belongs to that equation or not, you just take the x and y value of that point and plug into the formula. All right, so now we have said determine whether or not the given point is a solution of system. Okay, so we have these two. See, these are two separate lines, right? We discussed that on page 1. System means you have a pair of equations. When you have two equations, they call it system, means a pair. All right. So they give us this point. X and Y is 1 and 5. When we give you in the parentheses, means the first number is X and the second number is Y. Now, to see whether this point satisfies the system, it has to satisfy both equations. And you see it's not. Because when you put a 1 here, Y is 5. It satisfies this one, but not that one. Okay, so for this one, no. Another example, what about is X and Y is -3 and minus, what about this one? Is this a solution of the system? Okay, let's see. The first number is always X, the second number is Y. I'll take this and I put it in the first one. -15 is 5 times -3. You say yes for that one, okay? But it must satisfy both equations. Let's try it on the second equation. Y equal -6x minus 33. So I'll put that. I'll put a -3 here. Positive 18 minus 33, which is -15. And on this side also is a -15. See, both sides are equal. Then yes. Okay, so remember, when we give you a point and ask you to verify whether this point belongs to that system or is a solution of that system, means that point must satisfy both equations. Now, when you graph two lines and use the X and Y axis, let's say I have equation and I graph one line like this, and I graph another line, if two lines intersect at one point, we call this point solution of the system. Means this point of intersection of two lines, satisfy both equations. Okay? This is point of intersection is solution of the system. Now, let's see here. Is this problem here? Look. Question is this: use this graph to find solution of the system means read coordinates of this point. This is the point of intersection, right? What is coordinates of this point? X is, it has an X and Y, okay? X is minus 20 and Y is minus 15. It may not be very clear, you can see it here. You see? Coordinates of point of intersection is minus 20 and minus 15. That's how you find point of intersections. Solution of the system is coordinates of point of intersections. So if we give you a graph and we ask you to find this point, see this point is not given, you have to find it. If we ask you to find that point, you read coordinates of this point. You just say, okay, the X value and the Y value. So here, this is your X and this is your Y value. Now let's look at these problems. These two they have a parallel lines. Parallel lines do not have point of intersection. They never intersect. So when we ask you to find solution of the system, means find point of intersections, you just say no solutions. Why? Because two parallel lines do not intersect each other. So you have one point of intersection, you don't have any. So here, two lines intersect each other at one point. You see these two? Or if both lines are parallel lines, they do not intersect. What if two lines are like this? Look, if they both touch each other at many points. Then we say infinite solution. What's the case on that? Look, let's say I have an equation like this. I have an equation which is, I think I have it in the next sections. It's y equal 3x plus 1, and you have 1 is 2y equal 6x plus 2. These two basically are the same thing, these two equations. When you graph it, you come up with the same lines. And when you graph this one, you have the same line too. See, these two lines, they coincided. They both fall on top of each other. You see that? So how many points they touch each other? Many, many points. So problem like this, you just say infinite solutions because they touch each other at so many points. When they give you an equation, we discuss this later on, how do I know these two have infinite solution? First of all, you graph them. If both graphs are the same thing, then you know these two lines each touch each other at many points, or you solve it. And I'll show you how it works when you solve it later. So you have infinite solution, no solution in case of parallel lines, or one. Next is we give you equations and like this. Say graph the system of equations They give you this one. Again, we call it the system because there are two equations, right? So what you do is for the first one, you just say y equal minus 3x plus 8. Again, anytime you want to solve the equation, you need to have two arbitrary points, okay? So let's say one point is x equal 1, and this one. You put 1 here. Minus 3 times 1 is negative 3. Negative 3 plus 8 is 5. And you put another point. Let's say x equal 2. You put it here. 2 times, see, negative 3 times 2 plus 8 is negative 6 plus 8, which is 2. And as I said, you always need 3 points. It's better. It's safe to be true. You can also put a 0. 0 is a very good number to use. Why? Because when you put 0 here, see what happens. That would eliminate the first term. So y is 8. Okay. So, and now, so you graph this like, I have a better graph, I'll show you later on. So here you have something like, okay, x equal 1, y is 5, x equal 2, y is 2, x equal 0, y is 8, something like that. Okay, I'll show you a better graph. So that would be graph of y equal minus 3x plus 8. And then to graph the second one, it's y equal 8x minus 3. Same thing, you draw the table. Anytime you want to graph, always draw the table and come up with 3 arbitrary points. One of the good points to use is always 0, because when you put it here, again, 8 times 0 is eliminate minus 3. So it would be just minus 3. And then put 1. 8 times 1 is 8, minus 3 is 5, okay? Put 2. 2 times 8 is 16, minus 3 is 13, okay? So you graph these two. Now, graph of these two equations are here, look. One was, the second one was y is 8x minus 3. So when you graph these two, you could easily find the point of intersections. Okay, so this is graph of that is, and this, the black one is this one. Okay, so again, to graph, you always need to use at least 3 points. And then you could read this point. See, this point exists. This point, if I want to read the coordinates of this point, x is 1, and you go to y is 5. X is 1, y is 5. That's the point of intersections. All right? You know, we apply that in the word problems too. Like on your homework, there is a problems that it said gourmet apple sell chocolate and caramel covered apple for a law farmers market. You have these two equations. This is problem number 7 on your homework. Okay, so you have these two equations, R equal 16a, C equal 2a plus 700. And they want you to graph these two because they want you to find point of intersections. You know, this is very similar to this. Look, y equals 6x and y equal 2x plus 700. Okay, it's very similar to that. So like If I want to graph y equals 6x or r equals 16a, you just need 2 points, right? Or 3 points. So let's say, just say, okay, x is 0, y is 0, x is 1, y is 6, x is 2, y is 12. It just when you want to graph it here, instead of x and y, what should I use? A, this is A, right? And y-axis is either r or c, it doesn't matter. So to graph this one is 0, 0, for instance here, right? 1 and 6, so it's x in 1, 1, 2, 3, 4, 5, 6, is something like that, right? Goes that. You do the same thing for the second one too. For the second one also, you come up with 3 points. X equals 0, y is 700, x equal 1 is 702, x equal 2 is 704, stuff like that. And remember, you don't have to use the same scale because you don't have room for 700. So for this one, you could pick the scale like 10, 20, 30, but the other ones you could have the scale of 100, 200, 300. So this is up to you what the scale to use, as long as you use the equal sections. But x and y axis or horizontal vertical axis do not have to have the same scale. So when you graph these, you see something like this, look. So this one is 16a, or r equals 16a. And the other one is c equal 2a plus 700. And this is point of intersections. And you read the coordinates of that point. So when I want to read the coordinates of this stone, I just go a line like that. That give me 50 here, and I go like that. That give me 800. So if they say, what's the point of intersection? You just say x is 50 and y is 100. This is A and this is like a C or A or R. It doesn't matter. Both are the same thing. Okay? And you understand, anytime you want to know whether your point is, this point is correct or not, coordinates is correct or not, you could check, you know, this X and Y or 50 and 80, you could take it and substitute in both equations. If you satisfy both equations, then you know your answer is correct. Like if I put a 50 here, look, R is 16 times 50. R is 16 times 50, which is give you 800. Okay, you could also put it here too. C is 2a plus 700. So C is 2 times 50 plus 700. That also give you 800. So you know the answer is correct. So anytime you want to, when you find a point of intersection, if you want to know whether it's correct or not, it has to satisfy both equations. Means if you take X and Y and substitute in the equation, both must be satisfied. All right. This problem, they ask you, determine how many solutions to the system are there. You don't have to find a solution to the system, just say how many. Point of intersection is solution of the system, right? So look, they have only one point of intersection. So the solution is 1. Point of intersections. There is just one point the lines intersect. They call this point of intersection or solution of the system. System is again 2 lines. How about this one? Do they intersect? No, these two are parallel lines. They never intersect, so they don't have point of intersection. See, no solutions. That means they never intersect. These are actually two lines, okay? Since they both coincide, you don't see it. So let's say the other lines is come next to this one. See, red and black. So they touch each other as many points. So it's infinitely many solutions. That means two lines, again, remember, two lines intersect at one point. When they are parallel line, they do not intersect or they don't touch, but when they are together, they touch each other as many points. See, they touch each other as many points. So many solution or infinite solution. And this is the case here. All right. Next, we want to know how to solve the system. When you have a graph, see here, when they give you the graph and you see point of intersection, you could read this point off of the drawing, right? What if you give you equation and ask you to find that point? Let's say you have this equation. You have y equal minus x plus 7 and y equal 4x plus 6. There are three methods to do. One is method of graphing, which we discussed already. You just graph each equation and use the same x and y axis. Which one was method of graphing? You know, the one that you graph each line by using 3 points, and then you find this. That's the method of graphing, which we discussed. Another one is method of substitutions. Method of substitution is this. Look, they both are y. Y is equal to this and also y equal to that. So if you said y and y are the same thing, then you have 4x plus 6 equal to minus x plus 7, okay? Means basically you take these, right? Y is equal to that, right? You take this and you put it for the y at the top. Y at the top, you could use this one because this is y equal to that. It's like, look at this equation. What if you have like y equal x plus 1, and I tell you y is equal to 3? How would you solve this one when I say y equal to 3? Don't you take this 3 and substitute here to find the x? Same thing. Here, y and the second equation, y is equal to this. You take this y and substitute there. This is method of substitution. Then we solve it. So we get positive x minus 6 minus 6. 5x is 1. Divide both sides by 5. X is 1 over 5. Remember, when two lines are intersecting, they have x and y, right? What you did was you find the x. What about the y of this point? Anytime you solve the equation, you solve a system, when you find the x, you need to find the y too. How do I find the y? You could take these and substitute here in one of these two equations for x. It doesn't matter which one, either one give you the same answer. Okay, so let's say I take this x equal 1/5 and substitute here for this. So y is minus x plus 7, which is now minus 1/5 plus 7 over 1 kind of weird number, is 34/5. So this question mark for the y now is 34/5. That's how to solve the equations, use method of substitution. So for method of substitution, first you find the x, then you take and substitute in one of these two equations to find your y value. There is another solve the system. Solve the system by substitutions. If you don't specify what method, then you could use any method, graphing, substitution, or elimination, which I explained. Very soon. Y is 4, and 3x plus 2y is -5. Look at this one. Y is 4, so all you need to do is take this y and substitute here. So it would be 3x plus 2 times 4 is -4. So it's 3x plus 8 is 5. Okay, and y is 4. So the point of intersection is this. Okay, so now we want to introduce the last method. They call method of eliminations. Oops, method of elimination, or sometimes they call it addition and subtractions, right? So method of elimination is like this. What you see on this side on the right side, what do I have? I have 4 and -20, right? That would be -16. What do I have on this side? 2y and -2y cancel. -4x plus 8x is 4x. Okay, so then you divide both sides by 4. That gives you the value of x. Now remember, you always have x and y because point of intersection has x and y. So now you could take this x and substitute in one of these two equations. It doesn't matter which one. Let's say the top one is this. And you have -4 So point of intersection is what? Is -4x and -6. This is method of elimination. So method of elimination, it kind of combined two methods. It has elimination first and then substitution. You see that? First we eliminated y and then we use substitution. You could also use elimination 2 times instead of elimination and substitutions, okay? So when you find your x and you want to find your y, you could also do it this way. Use the red pen so you could see the difference. All right, so now I want to eliminate x this time. I mean, y this time, I'm sorry. I want to eliminate y, right? Let's look at it. What do you have on this side? You have -x and 8x. If I want to eliminate these two, I have to multiply the top one by 2. Because if I multiply the top one by 2, then I have -8x and 8x cancel, right? So you don't have to touch the bottom one. The top one you multiply by -4. But you bring the 2 and multiply by each term, especially the term that you have on this side. Don't forget that. Because you have to keep the balance. So this is -8x plus 4x equal to 8. See? And the bottom one is 8x plus 4x, 8x minus 2y equal to -20. Now, when you add these two, look, this cancel is 2y is -16. I'm sorry. Y is -6. See, you come up with the same value that you did here. Look. Here, I use method of elimination 2 times to find my x and y. So you either have a choice of using method of elimination 2 times, or just use elimination and substitutions. Elimination is always easier than all to use. You know, before I eliminate x or y, when I want to solve the system, if you want to eliminate x, you could just multiply the top one by what? Look, if you want to eliminate x, you have x at the top and 3x at the bottom. So all I need to do is just put what? Put -3 here to make it -3x and 3x cancel. So, but it sounds like it's easier if I eliminate these two, because the only difference between these two is both are positive. All I need to do is multiply one of these two by -1. Doesn't matter which equations. So if you bring that -1 and multiply by each, then you have this. X is minus 18. And if I want to use substitution method, I have X plus 3y equal to 9. I'll take this X and I'll substitute here. 3y is 27, and y is 9. So point of intersection is minus 18 and 9. Now, let's look at this one. If I want to eliminate X, you know how you have minus X here? You need to change this to minus 5X. So all I need to do is multiply the bottom equation by 5 to make this minus 5X, okay? What? When you see something like that, 0 equal to 0, you cannot come up with X and Y, right? You say infinite solution. Infinitely many solutions, or many numbers. Why? Why is happening? Because both equations are almost the same. Look, you see that top one? If I divide everything by 5, what do you see? X minus 3y equal minus 3. And if you multiply it by negative, you get the same equations. Look, that's why. It's the same equation. So when you graph it, you see both lines coincide or overlap. So let's say I want to create a problem that you end up having 0 equal to 0. One equation is 3x plus 1 equal to 2, right? Then I multiply everything by 7 and I read you another equation. 21 plus 7 equal 14. And I ask you to, first, when you want to start a problem, it appears that these two are completely different, but they are not. They are the same thing. All I did was I multiplied this by 7 to create that. So when you graph it, you end up having the same line. That's why there are infinite solutions, because both lines are the same thing. They touch each other at many points. Now let's look at this one. And the top I have minus 12, at the bottom I have 4. If I want to eliminate this, all I need to do is multiply bottom by 3, right? Because that would make it 12. Or if you want to eliminate y, all you need to do is multiply this by 3. So it would be positive 3y and minus 3y cancel. So it's your choice, okay? So it would be like that. So the top one is minus 12x minus 3y is equal to 4. Bottom one is 12x plus 3y equal 15. Everything canceled on one side, it's 0 on the other side, you have 19. That is sign of two parallel line. When you graph it, you see two parallel line. When you have two parallel line, you come up with something that doesn't make any sense. You don't find x and y, but you have like 0 equal 19, 7 equal 7, something that is not right. Then it's two parallel lines and no solution, means there is no point of intersection. Remember, solution means point of intersection. There is no point of intersection. And the last one is sometimes we have a problem like this, like 13x plus 2y equal minus 43, and 10x minus 3y equal minus 24. This is another one. So in this case, it's kind of weird because if I have 13x and 10, so what should I multiply this to make it 13? Or I have 2y and minus 3, what should I multiply this to be equal? In that case, we call it interchange. Means you bring this, you multiply the top one by 10 and multiply the bottom one by 13. But if I do that, then I have 130x and also 130x. One of these two has to be negative. Okay, so just put a negative in front of one of these two. It doesn't matter which one. So then make it minus 130 and 130. So now bring it and multiply by each. So it would be minus 130x minus 20y is positive 430. 130x minus 39y is minus 11. This cancels. Minus 59y is equal to 430 minus 1. Yeah, this is very weird number. Where's my calculator? Yeah, let me double check. Something is not right. Oh, I'm sorry. See, 13 multiplied by 24. That's a very large number here. No wonder. So it would be 24 times 13. It's negative 312, so it's better now. It's 118. It's y is what? Negative 2. Ah, still better. And then you could take this and now you substitute one of these two equations. Sorry about that. 13x plus 2 times negative 2 equal to minus 43. 13x minus 4 is minus 43. X is minus 3. Okay, so this is a type of problem that you cannot really multiply just one equation by a number. So it's the interchange. All right, so that would be end of chapter 4.